Hey everyone, and welcome to this explainer. We've got a lot of ground to cover, so let's just jump right in. We are currently watching a massive fundamental shift happen in the world of software development. Seriously, we're moving away from the era of simple line-by-line AI autocomplete, and we're stepping fully into the age of autonomous, repository-wide coding systems. It's no longer just about, saving a few keystrokes here and there. It's about fundamentally changing how we build, manage, and scale software.
Think about this for a second. Is your AI just typing, or is it actually engineering? It's a really crucial distinction to make. For a long time, AI coding tools have basically acted like incredibly fast, highly skilled typists, right? Predicting the next word, completing a loop, maybe filling in some boilerplate code. But the true leap forward, the one we're unpacking today, challenges us to look at whether our current tools can act as true engineering partners. Are they actually capable of managing the software development lifecycle, reviewing massive code bases, and executing complex, multi-step plans?
All right, Section 1, the AI developer workflow.
When you look at a developer's daily inner loop, there is a stark contrast between standard chat workflows and agentic workflows. With chat, your verbs are pretty passive. Think, understand, compare, explain. Like if you need to figure out what some legacy ASP.NET Core service does, sure, you use chat. But true productivity unlocks when you transition to agentic workflows. Here, the verbs become active: change, verify, update, rerun. You're moving from just asking for explanations to actually delegating bounded execution. You aren't just asking, hey, how do I fix this? You're explicitly instructing the AI to fix the root cause, rerun the tests, and summarize the diff. It's a totally different ballgame.
Now, to make these agentic workflows actually work, you have to treat the AI like a teammate. And to manage this new teammate, you have to name your constraints explicitly. You've got to tell Copilot exactly what must not change. For instance, you might instruct it to preserve your dependency injection registration styles or keep the public API completely untouched. And this is absolutely crucial. When the AI comes back with a solution, you review it exactly like you would review a pull request from a human coworker.
Moving right along, Section 2, choosing the right brain.
So not all AI brains are built the same, which means picking the right tool for the job is essential. Ask yourself, do you need the fast, snappy responsiveness of GPT-4.1 for a quick chat, or maybe a customer service bot where low latency is everything? Or do you need the deep, deliberate thought of GPT-5 for a complex architectural refactor? GPT-5 is built for deep reasoning and multi-step logic, which inherently means higher latency. It takes time to think. GPT 4.1, on the flip side, is optimized for high-speed, high-throughput enterprise applications.
The cool part is developers now have unprecedented control over this dynamic. GPT-5 introduces adjustable reasoning levels, ranging from minimal all the way up to high. This gives you, the developer, direct control over the time and tokens the model spends thinking before it outputs any code. If you're doing a really simple transformation, just set it to minimal for the fastest, cheapest result. But if you need complex planning and multi-hop reasoning for a really difficult bug, you crank that dial up to high. You are literally budgeting the AI's cognitive effort.
Let's zoom out a bit. Section 3, the repository level challenge. Think of it like an orchestra. An AI fixing one single function, well, that's like a solo musician playing their part beautifully. But updating an entire repository, that requires a conductor. The formal academic formulation of this problem shows exactly why standard large language models fail here. Code within a massive repository is just so deeply interdependent, and the entire code base is simply too large to fit into a single prompt's context window. You can't just copy and paste an entire enterprise app into an LLM and say, hey, update this. No way. It requires strategic, step-by-step execution.
Which brings us to Section 4, planning the code. Enter Code Plan. This is an architectural framework developed by Microsoft Research that acts exactly as that conductor we just talked about. It takes the repository and the initial seed specifications, and then the LLM merges with an incremental dependency analysis to create what's called an adaptive plan graph. It doesn't just guess. It actually maps out the dependencies, evaluates the impact of the changes, and executes a multi-step chain of edits. And once an edit is completed, the system analyzes if that edit broke anything else, continuously adapting the plan until the entire repository builds successfully.
Let's walk through an example. Imagine you have a complex numbers library and you change one single API. Okay, that's your step 1, the seed edit. Now, because of that one change, CodePlan immediately triggers step 2, change may impact analysis. It automatically traces every single file, every call or function in your entire codebase that relies on that library.
Then, in step 3, adaptive planning, it synthesizes derived edits for all those other files. It fixes the ripple effects automatically so your build doesn't break. It's not just writing code anymore, it's managing the consequences of that code.
Section 5. Microsoft's next move.
So, according to recent reports, Microsoft is expected to unveil a suite of homegrown AI models at the Build 2026 conference. This includes a specific coding model aimed directly at supercharging GitHub Copilot. What we're seeing here is a major strategic shift. Microsoft is reducing its reliance on third-party models from companies like OpenAI or Anthropic in favor of its own MI-series models. This move allows them to gain much more control over cost, latency, and enterprise governance by optimizing inference directly on their own Azure cloud infrastructure.
And the stakes of this shift, they are absolutely massive. Reports indicate that competitors in the AI space, like Anthropic, are reaching a staggering $47 billion annualized revenue run rate. I mean, the demand for these tools, particularly AI coding assistants like Claude Code, is explosive right now. This proves exactly why Microsoft needs its own cost-effective models. If they're paying a huge premium to third parties for every single line of code generated by Copilot, the economics simply won't scale.
Because ultimately, the core issue comes down to this. The model is not just suggesting text anymore. It is acting inside the software development lifecycle. Remember those agentic workflows we discussed earlier, where the AI verifies updates and reruns code? Well, those actions burn through compute tokens incredibly rapidly. Because these agents are doing so much more heavy lifting behind the scenes, Microsoft absolutely has to own the orchestration layer to optimize the economics of Copilot.
So as we wrap up this explainer, I really want to leave you with a provocative thought to chew on. Will the future of coding belong to the company with the absolute best AI model, or the one that seamlessly controls the entire workflow and economics? We are clearly moving from a world of simple autocomplete to a world of autonomous software agents. How your tools are powered, and more importantly, who controls that power, is going to define the next entire era of development. Thanks so much for joining me today, and keep learning.